Hello everyone, welcome to my YouTube channel Data Partnership. Today I will show you how to create flood risk maps using Google Earth Engine. In my previous videos, I showed you how to download digital elevation model, land cover and other indexes like NDVI and DWI using Google Earth Engine. So in continuation of that, I wanted to show you that how to use those data set um, in our applications. So in this case, it is flood risk maps. So in this dataset, only thing what additional dataset we'll use is water occurrence datasets. In videos, I will share those in description box. So we have calculated how to create a slope maps using digital elevation model. So in this case, how to use those dataset, this you will see. So what does occurrence means that it shows how often water was detected in each pixel over time, right? So every data set have pixels. So if 100% water, then it means that water present all the time, like river. One of the portion of the river, every lakes, right? So 50% means like floodplain, seasonal wetlands. Those water available in those bodies during the flood time or in the rainy seasons, like that. 0% means no water detected, right? So we are using global surface water. This is almost, I think, 20 years data we are using. So based on that, we'll see how to use those, right? So let's start it. So I have Google Earth Engine here, right? So this is flood risk. So what the first step is, we have done earlier also. We can see any area, maybe better to uh, let's see, any area. So we will see the upstream of Delhi. You can take your area, right? So we have taken this, right? So this is our study area. So how to we'll make that, we will make the center, so that I will just copy paste here and we will run, right? So it means map will be like that, in the center. And next is, now we will load the full global surface water data set, right? So we will just copy here from here and we will paste. So we can run this also. So, so to know more about this is, you just copy paste this data set here. So this is a JRC Global Surface Water Mapping Layer. You can just read about it, what it is, right? So you can see that this data set contains map of the location and temporal distribution of surface water from 1984 to 2021. Basically, it's provide statistics on the extent and change of those water surfaces. So you can read here, and band, you can see occurrence means the 100% with the frequency with which water was present, right? So we have different bands here. So we are using occurrence. So and the data set resolution is 30 meters. So this is the citation of this data. So wherever you use your, if you are using this data set for your project or somewhere, so please take this citation, because since here I'm just showing an sample, so you can use this, right? So what next is that now if we display globally this data, when you write this and run, right? So you can see, you will see all the data set around the globe, right? And okay, this is the center thing. And if you want to add this on map, then you have to write this. I'm just copying paste, because I have done already this one or two many times. So to for the redundancy, because sometimes typing error can happen, or it takes time also. That's why I'm just copying paste here, copying and pasting. So you can see this is the data set, right? But our intention is to, this is the data set for whole world, right? and what is our intention? Our intention is to for this our study area. You can use your own study area. So what next is so now we will use for our this data set for our study area. So how to do that? So we have already I have written here. Only thing is that we have to click AOI or geometry right? So in this case this will not. So now we can run it, right? So it means that now I'm using this data set, and this is the this will be the same, right? Then next is that how to load DM and slope. Now I will just copy paste here from here and just copy and paste, run the things. So what is slope? Okay, you run it. So it works. So you can see the so we have added slope and DM data with this study area, right? So what next is that now we have to define some parameters here. So now what we are just copying paste here. So what is this? So basically this is important thing actually. So we are defining the slope means if slope is less than 3 degree, right, or 10 degree, whatever. So I'm just taking 3 here, right? Or so how to calculate the risk then if water is greater than 50%, if 50% is greater than water, then you can see that means 100% means this all the time water is there. 50% means seasonally. So we have 50%, 60%, it all depends, right? So low slope means if slope uh, is 3, slope is less than 10 or like that. It all depends on the area, because since my study area is somehow plain area, and then DM is less than 260 meters. So in upstream of Delhi, the elevation is floats from 240 to 250 to 60. So I have taken just example. You can use uh, your data set accordingly, and then I will add this data. It will calculate the flood risk. So now we have to run the data set, right? So it may take some time, right? Because it is first loading DM, then slow, then flood risk, right? Based on the parameter that we have defined above. So after this, what will happen is that it is showing how the data wherever is flood risk is there, then it will show the red color, right? So it means that in our area there is not much slope. If we slope here, if we put 5 here, or is greater than 60, or it all depends. Then how do you can change your parameters, right? So you can see. So you can see this is this these are the it is loading in the map on the map. So you can see, right? And so what we did is suppose this is just I have taken the sample area. If we move this somewhere here, like, then we will see the real picture, because there is not much flood risk areas there. So if you use another area, so I have taken this area, right? So you can see there are some red patches here. So it's a low loading. Yeah, you can see this is red patch, right? Here is red patch, or somewhere else maybe. So it all depends. Then you have to change the elevation, or to change the water occurrence. So accordingly, you can see here. here also we are getting few flood risk areas, right? So because I have changed the area, you can, because I'm just taking the example. Basically my intention is to show you the process. You can, rest you will use your data set, you can add more data into it, land cover map also, you can use other cross sections also, because then hydrological and hydraulic modeling is also required, that is different story. So that those, this is purely based on the satellite product whatever is available. Based on that you can get some idea about the what are the flood risk area, and accordingly you can put more detail in your data. So what next then? Then what we will do is we will just so what we did here, create a simple risk index by combining high water occurrence more than 50%, low exposure less than 5, and low elevation less than 260. So sometimes its area is maybe 270 or 300. It all depends on what is the overall average elevation. So based on that, you can put your elevation data. So now what I will do is I will next is to how to this export this data. So I am in my every videos I am just using this export export data, means how to export the output. So you just run it, right? So line protein. So it is geometry. Here my you can put AOI also in place of geometry. So since I am using geometry everywhere, so it is geometry. So now if you run it, then here also yes, it is geometry. Geometry, right? So since, so task is that flood risk map. You run here and it will come. It will go to uh, your Google Drive. Since I have already downloaded for some other area, so it will be like that. Means we will have two area, two bands. One is zero. Zero means that is other than the flood risk areas. So these are the flood risk area. Means these are the area where there may be a flood problems, right? So you can upload your other layers here, means district boundary, block boundary, village boundary. So accordingly you can get the how much area is how much area flooded or how much people are living uh, in that area. So you can do a lot of analysis based on this. So this is for another area, basically near to this only, but because since it is taking time, maybe here in early it took 5 minutes, so that's why I have already downloaded. You download and accordingly you can do your other things, right? And you can use this one also. Accordingly it will show you like this, you know. So yellow part is basically the flood areas. So that's it guys. So in my next video I will show you how to add land cover map, and so I will add more data set into it, so that we will get more detail about the flood, because this is very simple example to show you how to do the things, right? You will use your own data set, your area, because now monsoon season is going on, a lot of flooding. So you can use other data sets also explore more data set, how you can use this open source data. So what I will do is I will also try to find out what are the other data sets and how we can use in our project or for capacity, how to improve our capacity, right? So this was my intention. I hope this will help you, and you can create project. Means if you are a student or researcher, then you can use this data set or this process, and you can add a lot of other things, because I am not the core programmer, so I am just learning from here and there and giving you the direction that how to do that, right? So please subscribe my channel and distribute it, share it, so that I will come with more lot of very interesting videos are going to come in future. uh, so thank you very much.